Assembler instruction sets. An instruction set is a list of every assembler-level instruction that is available for a given microprocessor. What makes things interesting for us as programmers is that each manufacturer has its own unique set of instructions. They all do the same kinds of operations, but each has its own unique style. Regardless of the manufacturer, all instruction sets have the same capabilities. First thing you'll always find is the ability to move data around. You may want to move it into or out of a register or a memory location, or to get data from or send it to an external device that's connected to one of the ports. Whatever data you need to move, there will be an instruction to do this. You will also always find instructions to perform arithmetic and logical operations, and to test or manipulate values. There will be some sort of instructions that allow you to modify the sequence of your programs by including decision blocks and repetition loops. The last set of instructions that you will always find are ones that allow you to work specifically with the status and pointer registers. In the next few minutes, we'll take a look at each of these types of instructions. There are 4 reasons for moving data within a microprocessor system: initializing, storing, repositioning, and reading back. Regardless of the purpose, there will always be 2 elements involved: the source or starting location and the destination or final location for the data. The source may be a constant value, be stored in a register, or be stored in a memory location. The destination will either be a register or a memory location. Normally, an initialization operation requires moving a constant value into a register. The instruction to do this will usually be either a load or a move. The source is the constant value, in this case a 42, and the destination is one of the registers. A store operation means moving a value from a register out to a memory location. The instruction to do this will usually be either a store or a move. In this case, the source is a register and the destination is a specific memory location. A repositioning operation usually means temporarily moving values from one register to another. The instructions available to do this are either transfer or exchange. For this type of operation, both the source and destinations are registers. Finally, a read operation means moving a value from a memory location into a register. The instructions available to do this are the same as the initializing ones, either a load or a move. In this case, though, the source is a memory location and the destination is a register. Arithmetic and logical operations are generally a 2-step process, each step involving both a source and a destination. The source may be a constant value or come from a register or a memory location, while the destination is normally a register. The first step in an arithmetic or logical operation is to initialize the destination register to the first of the 2 operands. A load or a move instruction initializes this register to a constant value or to one that's currently stored in a memory location. The second step is the actual arithmetic or logic. The second operand might be a constant or a value currently stored in memory, and the operation is performed using an instruction such as add, subtract, multiply, divide, logical AND, or exclusive OR. Depending on its complexity, testing or manipulating values may be a 1 or a 2-step process. The simplest of these operations is clearing a register or a memory location. In this case, there's no source, just a destination. Look for a clear instruction to do this. If there isn't one, then you'll have to initialize the destination to the value 0. The rest of the testing and manipulating instructions require 2 values. One, a source in a register, and the other, a constant, stored value, or another register. Normally the process is 2 steps. First, load or move the first value into a register. Then perform the desired operation using the compare, test, bit set, bit clear, or bit test instruction. If you're doing a manipulation instruction, the destination is the same register that you originally initialized. If, however, you're doing a test or a comparison, the result of the actual operation, which is usually a subtraction, will not be stored anywhere. The only thing that we changed is the status register, where the negative, 0, overflow, and carry bits will all reflect the status of the last operation. Most assembler programs are not just a sequence of operations that always get executed in the same order. There are usually decision blocks, repetition loops, and subroutines that change the program flow. There are 4 main instructions to do this: branch, jump, call, and return. Branches and jumps are used for decision blocks and repetition loops. Jumps and calls are used to execute subroutines, and returns get you back from those subroutines. There are 2 main tasks performed on the pointer registers: initialization and modification. Initializing a pointer register uses the same instructions that are used to initialize an all-purpose register, either a load or a move. The source might be a constant, or it might be stored in a memory location. Modifying a pointer register implies that there's already something stored there. If so, you can perform operations like increment, decrement, and clear. These instructions are found in any instruction set. Because the status register is really a collection of individual bits, the most commonly done operations are set and clear. Sometimes these instructions require you to use a generic bit set or bit clear instruction, but normally there are specific instructions provided to set and clear each of the bits in the status register. Look for them in the clear and set sections of the list. So we now know that all instruction sets provide ways to move values, to do arithmetic and logical operations, to test and manipulate values, to control program flow, and to work with the status and pointer registers. What that means to you as a programmer is that you really need to familiarize yourself with the instruction set, and then based on the type of task you need to perform, choose the right instruction for the job. So we've talked about what's the same amongst different instruction sets, but now it's time to take a quick look at what's different. It's really quite simple. First, each instruction set has a different number of instructions. Some have lots, with many specialized instructions, and others are called reduced instruction sets and have very few, but much more general instructions. Secondly, each instruction uses its own specific mnemonics or keywords to represent individual instructions. They're usually just a few letters long, so it's your job to really get to know what's available in your instruction set.